guys. So today we are doing lesson 73, which is all about geometric transformations. And those of you who are in Miss Jen's class will probably recognize this at least a little bit. Basically, what we're doing is we're going to be doing a little bit more geometry work. And we've already kind of been doing this because geometry is like all about shapes and lines and angles and stuff like that, which we've already kind of started doing. For example, a couple lessons back, I talked about congruent shapes, which are shapes that are the same shape and size as another shape. For example, if I have two squares that are the exact same size, they are congruent. If I have two circles that are the exact same size, they are congruent. If I have a big square and a little square, then they are similar because they're both squares, but they're not congruent because they're different sizes. The reason I bring up congruency is because today's lesson actually has to do a little bit with congruent shapes. So like I said, congruent shapes, they're the same shape and same size, but they can be in different positions. The math term that they use is actually, they say they are in different orientations. So for example, in this picture, all four of these triangles are congruent, as it says there, but they are in different orientations. Triangle 1 is just kind of hanging out there, being chill. Triangle 2 is up in the air, being an airplane in its dreams. Triangle 3 is not the same exactly as Triangle 1, but it's pretty similar. And then the last one, Triangle 4, kind of looks like a shoe on the ground. But they're all congruent, they're all the same shape, all the same size, they're just in different orientations. One thing that sometimes happens in geometry and with geometric questions is they will ask you to reorient one shape so that it either looks the same as another shape or so that it's laying on top of another shape. You might recall, again, if you were in Miss Jen's math classes, you might remember that we would sometimes have things that we would turn, or we would flip, or we would slide. In geometry, those are things that we do. We just use different terms. So these movements are called transformations. And so for transformations, if you are going to slide, then the math term for that is you're doing a translation. You are translating it from one side of the paper to another. I don't know why it's called that either. It's just weird. If you are turning it, you are doing a rotation. You are rotating the shape. So a turn is a rotation. If you are flipping a shape, that is called reflection. Like we're looking in a mirror and you see the reflection and it's flipped. So slide is translation, turn is rotation, flip is reflection. Those are the terms that I would like you to try to use when you're doing this kind of work. I will accept the slide, the flip, whatever the other one was. I'll accept those, but it would probably help you to just kind of ease into that new language. Same concepts, just new language. Okay, so enough of that nonsense. So now the first question for you is, which transformations would move triangle 2 to the same orientation as triangle 1? So as I mentioned earlier, the transformations are the movements themselves, and orientation means position. So in this case, we want to move triangle 2, the one on the right there, triangle B, we want to change that one so that it has the same orientation, the same position as triangle 1, triangle A. So the way we would do that is, first things first, we are going to rotate. So we would turn that so that it is on its side. And for this question, that could be an acceptable response, just ending it right there. But you could also say that you're going to translate it, slide it over so that it's laying on top of triangle 1. That is also acceptable. That's really all that is. Just moving things around. So the next one is a question that I think will probably help in the lesson itself. And this is, which transformations would position triangle ABC onto triangle CDE? So first things first, triangle ABC is the one down on the bottom right there. And triangle CDE is the one on the upper right-hand piece. So we are going to move triangle ABC so that it is on top of triangle CDE. The order doesn't really matter, kind of. Not really matter. It doesn't really matter. But for this one, what we would do is we would rotate it so that the ABC was basically sitting up straight. And then we would do a reflection. So we would flip it. And then that would be it. It would be right on top of triangle CDE. That's it. Yeah. This is one of those things where being in the classroom would be really helpful because I could actually like show you and have like a triangle and like turn it in shapes, but I don't think I have any congruent shapes that are not squares in my room. So if you wanted to, you could actually cut out some little triangles, like get some spare paper and just draw some elongated triangles that kind of look like the ones in this lesson and use those physical cutouts, and that might help you to figure out how to move it exactly how to orientate it. If you want to do that, I encourage you to do that if you think it would be helpful to you, because that would be very helpful. So that's all I've got for you today. So go ahead and work on lesson 73 and let me know if you need any help. And I'm sure this didn't make a whole lot of sense, and I'm sorry. But I can do my best to explain it another way if you need me to. Okay? All right, I'll see you guys tomorrow. Bye.